Hey guys, in this video the lovely Miss B is going to be taking you through differentiation. Now this will be for your further maths, GCSE, or as an introduction to A-level if you want to get a bit of a head start over the summer. Now in this video there are 9 examples worked through at a nice slow pace and everything fully explained. But if you want more practice, if you want to properly check that you've understood everything, then over on the website there are thousands of practice questions and a massive workbook for you to go through.
We are going to have a look at differentiation, and differentiation is the way to find the gradient of a curve. So what do you know about gradients already? Well, if we have a line, let's say y is equal to mx plus c, which is the usual format that we write a straight line in, the gradient, which we can say is the difference in y over the difference in x at a point on the line, is going to be m. So we've been saying before that the m in y equals mx plus c is the gradient. Now, how do we do this with a curve? Now, with a curve, there's a little rule we can follow. So let's say we've got y is equal to, and we've just got x to the power of n. So maybe it's x squared or x cubed. So how do we find the gradient, which is the difference in y over the difference in x? Well, what you do is you get the power and you bring the power down. And the power becomes a coefficient on the x, and then we take one away from the power. And that's how you find the gradient on a curve. So let's look at a couple of examples. So let's look at this linear one first. We've got y is equal to 2x plus 3. The difference in y over the difference in x. To find that, what we're going to do is we're going to take the power on the x. Now, there is no power on the x, so if you can't see a power, it's going to be power 1. I've not bothered to write it down. So we bring down the 1, and it combines with the 2. So we've got 1 times 2 is 2. And then the power on the x is going to go down by 1. So x to the power of 1 becomes x to the power of 0, and x to the power of 0 is 1. So we're just multiplying by 1 again, so we've got the 2. We can do the same thing with the plus 3. So we take the power on the x. Well, it's going to be an x to the power of 0 because there's no x there. So we're going to bring 0 down into our coefficient and multiply by 0. And if you multiply by 0, you get 0, so the rest of it's irrelevant. So you can use the method I've shown you here, or what we've done previously, just memorize, well, it's the number on the x, it's 2. It's the m section. But it's more useful when you have a curve where it's not immediately obvious where it's going to be. So let's say we've got y is equal to x cubed. So we get the power 3, and in the difference in y over the difference in x, the gradient, we bring the power down to be a coefficient on the x. If there's a coefficient already, you multiply them together. If there's no coefficient, it can drop down. And then you reduce the power by 1. So a cube is going to go down into a square. And so the gradient of x cubed is going to be 3x squared. So with that in mind, let's have a look at our question. So we've got the function of x is 8x cubed. Now we can write that as a curve. So we can say y is equal to 8x cubed. So if we want the gradient, the difference in y over the difference in x, dy over dx, we are going to bring the power down to 3, and we're going to do 3 times 8, which is 24. So 3 comes down into the coefficient. I guess a better way to write this is maybe to be clear what we're doing here. So let's write down the 8 times 3 first. So that's the coefficient on the x. The power's coming down and multiplying by whatever number's on the x. Then our power, I'm subtracting 1 from it. So if we work this out, 8 times 3 is 24. We have the x, and 3 take away 1 is 2. So the gradient of 8x cubed would be 24x squared. Now, the last thing to talk about is notation, because there's a couple of different ways to show this notation. So the first way is you can show that you are differentiating by having your kind of algebra written out as a line and have it be y equals something x. And you can show your differentiation, your gradient, by writing dy over dx. So that's the first method. Another way of doing this is that you can write down a function of x instead. So a function of x is 8x cubed. When you differentiate, you can say that f dash x is going to be 24x squared. So you use a dash to show that you've differentiated. Which one do you write down? Well, just look at the way the question is phrased. So if the question has f of x equals, then you want your answer to be f dash x equals. If your question is y equals, then your answer needs to be dy over dx equals. So moving on to our next question. First, remember what the rule is. If you have y is equal to x to the power of n, then to differentiate it, dy by dx, the gradient, would be equal to nx to the power of n minus 1. So you bring the power down to be the coefficient on the x, and you reduce the power by 1. So let's look at our question. So we have f of x is equal to 6 over x cubed. Now, this doesn't really match what we've got written over here, is it? And what we can do is we can kind of rearrange this, and we can say that f of x is equal to, and we can write it in a better format, and we can write it as 6x to the negative 3. And all I've done is I've taken the denominator, x cubed, and I've brought it up to the numerator. But if you do that, you need to make the power negative. When you think about your laws of indices, having a denominator power is the same as a negative power. Now I've written it in a more usable format, now we can find f dash x. We can differentiate. So we take the power negative 3 and we bring it down. I'm going to multiply it by the coefficient. 6 is going to be multiplied by the power negative 3. And then with x, our power negative 3, I'm going to take 1 away from it. So if we work that out, 6 times negative 3 will be negative 18. We've got the x. Then negative 3 take away 1 would be negative 4. So the gradient of 6x to the power of negative 3, the differentiated version, is going to be negative 18x to the power of negative 4. Now, why don't we write our answer in the same way our question was written out? So why don't we bring the power down to be a denominator? That's going to be the same as negative 18 over x to the power of 4. So again, just recognizing that a denominator and a negative power are basically the same thing. But if you do write your negative power as a denominator, then you need to take the negative symbol out. And again, this is going back to laws of indices. Now, which of those two answers do we need? Well, it doesn't matter. Either of them are going to do. You're only going to need one of those specific answers, either the one with a negative 4 power or the one with a positive 4 power, if it specifically asks, write it in this format. So it might say, write it in the form ax to the power b, in which case you want the first one, or it might say, write it in the form, and it might have a over x to the power of b, and write it in the form of it's got that kind of numerator and denominator involved. It's got the fraction involved, so you know you need to write your answer as a fraction. But if the question doesn't tell you, then it'll be fine with either. Moving on to the next question, again, we are going to differentiate, and again, the question's written in a form that doesn't really look like our rule that we've got over on the side of the page in pink there. So we need to kind of rearrange what we've got, rewrite it to be more in that format. Now, for this, we need to remember that when we have a root, we can rewrite it as a fractional index. So we've got 9x to the power of 2. Just remember that when we've got a cube root, we can rewrite the entire cube root symbol as a denominator of 3 on the power. So 9x to the power of 2/3 is exactly the same as the cube root of 9x squared. So we rewrite it so we've got an optional number, we've got an x, and we've got a power. Anything else, kind of rearrange it, rephrase it, something that means the same thing, but isn't as complicated to differentiate. So now with our differentiation, f dash x, we're going to take the power and bring it down. So we've got the 9, I'm going to multiply it by the 2/3. And then with the x, our 2/3, we're going to take away 1 from it. So a little bit of fraction skills going on here. So 9 times 2/3, so we can do 9 times 2 is 18, and have it over 3. I'm not explaining too much about how to deal with fractions, you should know by now. If you don't, go and have a look at one of our fraction videos. Basically, whole numbers can be written as a fraction, 9 over 1 for 9. So multiply the numerators, 9 times 2, and multiply the denominators, 1 times 3. And then 2/3 take away 1. Well, if we take away 2/3, we'll get to 0. And if we take away 1 more third, then we've taken away 3/3 altogether. So it's going to be negative 1/3. And we can clean this up. So 18 over 3 we can do. 18 divided by 3 is going to give us 6. it's going to be 6x to the power of negative a third. Now, again, there's a few ways you can rearrange this if we have to put it in a specific format. So we could write it as a fraction. We could have 6 over x to the power of a third. So swapping the negative symbol, make it into the denominator of a fraction. And then going back to what we did at the start, we changed a root 3 into a denominator of 3. And what do we have here? Well, the denominator of 3 on our power. So we could change that into 6 divided by the cube root of x. So any of those 3 answers is going to do. I'm just going to show you all 3 versions because you might be asked to write it in a specific way. It might say write it in the form something over a cube root. In that case, you've got to write the final version of this. If it doesn't ask you to write it in a specific way, then the 6x to the power of negative third is going to be absolutely fine. Now, for our next question, it looks like we've gone back to an easier one. Now, to write this out as a line, we've got y is equal to 5x squared. So we differentiated it to find the gradient, dy by dx. Then we bring down the power, 2 times 5 is 10. And then we reduce the power by 1. So power 2 would go down by 1 to be power 1. So far, this is pretty simple. But that's not what this question's asking for. This question is asking for d2y dx squared. And what's that? Well, that is a way to represent the acceleration, the kind of rate of change of the gradient. So how quickly is the gradient changing as you move along the line? And to get that, we just differentiate for a second time. So with the 10x, it's practically a 10x to the power of 1. So again, we bring down the power. So we have 10 times 1 is 10. And then the power on the x goes down by 1 to give us 0. And anything to the power of 0 is going to give us 1. So we've got 10 times 1, which is 10. So the kind of rate of change of the gradient as you go through the curve is a factor of 10. Now, again, thinking about notation, if our original question, if f of x equals, differentiating the first time will give us f dash x is equal to, and it was 10x. So differentiate for the second time, you have 2 dashes, f dash dash x, which is 10. So there's 2 ways to write it. You can write it as a line, like a y equals, in which case you have dy over dx and d2y over dx squared. Or you can write it as a function. We have f of x, f dash x, and f dash dash x. So for the medium questions, we're going to be differentiating twice. So moving on to the next question, we have f of x is equal to a 6x cubed. So differentiating that, f dash x is going to be equal to, we're going to multiply the coefficient on the x by the power, which is 3. And then the power on the x, we're going to take away 1. So 1/6 times 3 is 3/6, which is the same as a half. And 3 take away 1 on the power is going to give us 2. So differentiating once, we get half x squared. But in the median questions, we are going to be differentiating for a second time. And we just follow the same process. So we take the coefficient, the half, and multiply it by the power. And then that power is going to be reduced by 1. So you kind of think of like you've used up one kind of factor of the power. So we've used up the 2 and it's dropped down to 1. And by dropping down, we're using that 2 to multiply the coefficient. So we are using it for something. So to clean it up, we've got a half times 2, which is going to be 2 halves, which is a whole 1. And then with the x, we've got 2 take away 1, which is 1. Now, we could write this as 1x to the power of 1, but in algebra, we're not going to write a 1 as a coefficient. 1x and x are the same thing. And in algebra, also, we don't write powers of 1. We just assume that if you've got a letter and there is no power on it, it's power 1. And it's got no coefficient on it, then it's being multiplied by 1. So the second derivative, the kind of rate of change of the gradient, is x. For the next question, we have y is equal to 5x cubed plus 7x squared minus 1x minus 8. So for this, we've got 4 different terms. And all the previous questions, we've only had 1 term. So what do? Well, you just simply apply the rule to each of the 4 terms. And it's written as y equals. So we'll do this in the other form. So write dy over dx for the gradient. So for the first term, we start off with a 5, bring the 3 power down, and then subtract 1 from the power. For the second term, we have 7x squared. So bring down the power, the 2, and then take away 1 from the power. For the negative x, So what we're going to do is we're going to bring down the power. Well, it's a 1, isn't it? So we're going to be timesing it by 1. That'll make no difference. And with x, if you reduce the power, it's effectively a power 1 take away 1. So we've got 1x, and then the power is 1 take away 1. So all we need to do now is just go through and resolve all these calculations and neaten this up. When you get confident, you'll be doing a lot of this stuff in your head. So 5 times 3 is 15, and 3 take away 1 is 2. 7 times 2 is 14, and 2 take away 1 is 1. And then that's going to be 1x, and it's going to be the power of 0. 1 take away 1 is 0. Anything to the power of 0 is going to be a 1. So it's 1 multiplied by 1. So the first derivative is going to be 15x squared plus 14x take away 1. Now again, with the medium questions, we're also going to find the second derivative, d squared y over dx squared, the second derivative, and we're going to do the same thing again. So we start off, got a coefficient of 15, bring down the power of 2, and then take 1 away from the power. Then we've got a coefficient of 14, bring down the power. Well, that's effectively going to be x to the power of 1. And from x to the power of 1, we're going to be taking away 1. And then with the last term, we've got the negative 1. Now, with this, the kind of coefficient's 1, there's no x term, is there? Now, effectively, if there's no x term, it means it's an x to the power of 0. If we bring down the 0, what's going to happen is we're going to have 1 times 0, and then our power of 0, we're going to take away 1 from that. Now, work out the power doesn't really matter because we're multiplying by 0. And if you multiply by 0, you get 0. So effectively, the entire final term is cancelling itself out. It's gone. We're getting a 0 out of it. So we don't need to write anything. And you'll see in our original line, we had 4 terms. In dy over dx, we had 3 terms. And now in d2y over dx squared, now we've only got 2 terms. So what happens is any number is lost when you differentiate. If it's got an x on it, then it's going to still be there. But if it's got no x, it's just a normal integer number or a fraction or a decimal, whatever it is. If it's got no x, it's going to be disappearing. So now let's work out the final answers. So 15 times 2 is 30, and 2 take away 1 is 1. So we've got 30x to the power of 1. And then we've got 14 times 1, which is 14. And then with the x term, we've got 1 take away 1 is 0. So we have x to the power of 0, which is 1. So we end up with 14 times 1 again, which is 14. So our final answer is 30x plus 14. Now, to finish off, we're going to have a look at a few strange cases of differentiation. The first case is something like y equals e to the power of x. Now, e is a kind of a strange number. It's an irrational number like pi is that comes out of some mathematical calculations. Specifically, it's e because this constant comes out of exponential growth. Now, what is e? Well, e is equal to 2.718, and then there's going to be more 28, 18, 28. So the number's going to continue. Now, a weird thing about when you differentiate e, something strange happens. dy over dx for e, you'll notice that the x is the power. So it's not like you can use the rules we've just been using, because they're all about x being the kind of the number we're applying the power to, not being the power itself. Now, what happens is the gradient of a e to the power of x curve is e to the power of x. So it doesn't change. So that's something strange about the e rule. Now, how do we use it? Well, we've got f of x is equal to e to the power of 5x. So in this situation, the actual e to the power of x is not going to change. So f dash x is going to have e to the power of x in it as well. What you can do, though, if there is a coefficient on the x, you can bring that down like you normally would. So e to the power of 5x differentiates to 5e to the power of 5x. The power hasn't changed, but you can bring down the coefficient of the power to be a coefficient of the e. Another special case is that you can differentiate trigonometry. So if you have y is equal to sine x, you can differentiate that. And the way that sine x differentiates is that it becomes cos x. You can also differentiate cos x. And the way that cos x differentiate is to negative sine x. So let's have a look at a practical example. We have f of x is equal to sine 6x. So we're going to differentiate it and find f dash x. The sine is going to become a cos. The 6x is going to stay the same. So it's much like with the e, the bit with the x isn't going to change. But like with e, because we have a coefficient on the x, we've got the 6, we can bring that to the outside like you would with normal differentiation. So if we have a function of x is sine 6x, then the differentiated version of that, the first derivative, is 6 cos 6x. So moving on to our final example, we're going to find the second derivative of some trigonometry. So we have function of x is 4 lots of cos 4x. So when we differentiate it the first time, we're going to bring the coefficient on the x to the outside with a coefficient on the cos. The cos is going to change into sine. Remember, it's going to be a negative sign. So we'll make a little bit of room for the negative sign here. Put negative sign on the outside. And then the 4x, that's not going to change. So for our first derivative, let's clean this up a little bit. So 4 times 4 is 16. So we'll have negative 16 altogether. Negative 16 sine 4x. So now let's find our second derivative. So we have the negative 16 on the outside. We're going to be multiplying that by the coefficient of the x, the 4. Sin is going to become cos, and the 4x is going to stay the same. So again, in these special cases we're looking at, the actual, either the power or the thing in the brackets is going to stay. So now let's clean this up. So negative 16 times 4 is going to be negative 64, and we have cos 4x, and that's our second derivative. So we looked at the standard differentiation rules for the first 6 examples, and then for the last 3 examples, we've looked at a few special cases, the letter E, and we've looked at trigonometry, so sins and coses.
Ouch. Love you too, Prim.